Today we're going to talk about integration by substitution, in other words, U-substitution. We're going to start by stating that the derivative of a composition of functions will be using the chain rule, so the derivative of the outer times the derivative of the inner, and it therefore stands to reason that when you take the integral of that output, it'll return the input, which is the composition of functions, plus c. Let's do a substitution so that we're not looking at so much. Let's say that u is g of x, then du is g prime of x, and we can rewrite that integral statement like this. Let's practice recognizing the patterns. Let's find g of x and g prime of x for this integral. G of x is going to be your inner function, and therefore g of x in this example is going to be x squared plus 1. When you find g prime of x, you can do it by literally integrating g of x or by finding the other factor, 2x dx. And so I'm color coding the portion that it is representing. In this example, we're going to do it again. We're looking for g of x and g prime of x. One will be the derivative of the other. Let's do it again, but with trig functions. Secant squared is the derivative of tangent. And finally, we're going to do it, but instead of finding g of x, we're going to find u and du. We're going to see that du isn't actually what we have there. It's 2x dx. All we need is an x dx. So in order to solve that problem I'm going to divide by 2, and so du over 2 is actually what is representing x dx. Let's go ahead and solve it. So when we use the u notation, we'll pull a constant 1/2 out front, we'll integrate, we'll remember our plus c, and then we'll replace any u's with what they represent. And we'll get an answer of 1/8 x squared plus 1 plus c. I'm going to ask you to pause the video and attempt this one on your own. Here's what we're looking for. And you can pause the video now and give it a try and come back. Let's go. G of x is going to be 5x, and therefore g prime of x is 5 dx. That's what u and du are. Now we're going to evaluate. So what we're going to do is we're going to replace or substitute. That's why it's called U-substitution. So it's going to be e to the u du. E to the u plus c is going to be the integral. And then we'll replace the u with 5x. Let's go ahead and do a check on this just for fun. So we're going to take the derivative of e to the 5x plus c to see if we get back our original. So the derivative is going to be e to the 5x times 5. The derivative of a constant is 0, and we absolutely have. Now it's time for some challenge problems. Pause the video and give them a go, and then come back here and watch my solution. In this first one, we end up with 2 dx. We don't have a 2, so we have to get rid of it. So we have found dx, but we're missing an x. What do we do if we're missing an x? Well, we can solve for x. Look, u equals 2x minus 1. We can just solve it for x. And now we have all 3 pieces. Now we just need to be careful with our notation. You're going to notice that I'm going to go ahead and go very slowly. I'm putting everything up top in the numerator or denominator and separating them. I'm pulling the constant out front, and I'm rewriting my u's in terms of what they are in halves. And that's going to make it much easier to integrate them, even though perhaps annoying. I'm not going to forget my plus c, and I'm also going to use this step to just multiply by the reciprocal on each of the terms. Finally, that 4 is going to come in and end up being 2/20ths, or 1/10, and in the second term it's 2/12ths, or 1/6, and there's your correct answer once we replace the u's with what they substituted for. In our final challenge problem, we want to note that it's sine that is squared. So sine is going to be our u. Cosine is going to be, don't forget, using a chain rule here. And so we'll have to divide both sides by 3 to actually solve for the piece that is represented in the integral. Then we'll replace them, pull the constant out front, and then integrating u will be a breeze. Don't forget plus c. Now we're going to substitute back, and we're going to get sine cubed of 3x over 9 plus c.